Hello, welcome to the next awesome video. So, we're still in section 5.4 here, and we'll talk about the average value of a function. So, we can find the average value of the function with an integral. And so remember, when we talk about the value of the functions, we're talking about the y-coordinates, right? So, normally on an average, you add up everything, you divide by how many there are, right? So, but there's infinitely many y-coordinates on a continuous function. So if we want the average value, we use the integral to do that. Okay, so you find the integral over the interval. So that's just the area of it, right? And then you divide by the width of the interval. Because the width of the interval is kind of like the how many things there are in there. You can think of it kind of that way. So let's just say that we have the function f of x equals 2x squared plus 1. Okay. We want to find the average on the interval from 1 to 6. So easily enough, our average is just going to be 1 over 6 minus 1 times the integral from 1 to 6 of 2x squared plus 1 dx. So that's 1/5. Now that's going to be 2/3 x cubed plus x evaluated from 1 to 6. So 1/5 times 2/3 times 6 to the third plus 6 minus 2/3 plus 1. I just stuck 1 in there, right? 1 cubed is just 1. All right, so grab my calculator real quick. One-fifth, and that's going to be 150 minus 2/3 plus 1 would be 5/3, 7/3, no, 5/3, yeah. So that's 1/5 times 445 over 3. And that would be 89 over 3. And there's our average value for the y-coordinates over that function. So, woohoo! Now, we also have what we call the mean value theorem for integrals. It says that if f is continuous on an interval, then there exists a number c in the interval such that the y-coordinate is equal to the average value. So, I mean, picture-wise, if we have some function and we want to know the average value, over this interval or whatever, okay, then what happens is if you look at the area there, that means you can find so if you look at that area, that means there's some spot in here that if you looked at the area in this box, it would be the same as the area under the curve. And then that spot would be the average value of the function. So let's see if we can find that spot. Well, let's look at the last example that we had. We know that for our function, and we were looking on the interval from 1 to 6. What we're saying is that somewhere in this interval there exists some c such that f of c is equal to that 89 over 3. And that's guaranteed to happen somewhere in that interval. So the question is, what is that value? So we've already found our average value. So now we can just set that equal to 2x squared plus 1. Okay, and then we can solve that. So if we subtract 1 from both sides, that'll be 86 over 3 equals 2x squared. And all I did there was subtract 1 from both sides. We'll divide that by 2. And that's going to give me 43 over 3 equals x squared. X is going to be the square root of that. Now I have two options, one being plus, one being negative. But since I'm between 1 and 6, I know that's going to be the positive. And it turns out that if you look at the approximation, that's 3.79. So graphically, x squared plus 1, if we look at this from 1 to 6, and we look at our area under here, if we go over to 3.7, so it's up in here, and we look at this rectangle, we would have the same area in that rectangle as we would the area under the curve. There's your mean value theorem. It just says if you know the area average value of the y function, then there is something in that interval where if you evaluate the function at that point, you can use that as the height of your rectangle to find a box for the area.